I thought I might dot across 4 different topics to give you a sense of 4 examples of how we can use data that's routinely recorded for other purposes, and typically this is going to be transaction data, to understand something of human behavior. So I want to look at some work on gambling. I'll tell you a bit about how people's brains represent numbers, because it's perhaps not how you think. This is an image from a domestic abuse, or I guess it's an anti-domestic abuse advertising campaign, and we'll talk a bit about what we can learn about domestic abuse from big data. And then if we've got time, we can talk a bit about how we can use big data to understand what's been happening to our spending during coronavirus. So let's have a look at gambling first of all. And this is the project that Naomi led. So this is a WhatsApp I got from my mum. And it's a headline from the Daily Mail on Thursday. And the headline is, "Heavy gambling can increase your risk of dying by 1/3, study warns." Now, unfortunately, this is about the work that we did, and it's completely not true. And there are 2 terrible mistakes in this headline, and I'll tell you about what they are. Luckily, I trimmed off the rest of the WhatsApp chat so that you can't read what I messaged back to my mum. But there are 2 problems. One is our study doesn't show that gambling causes any kind of harm. The word causes being absolutely key there. And the second thing is risk of dying by 1/3. That sounds terrible. But actually, the risk of dying that we talk about in our paper, it does go up by 1/3, but it goes up from 50 people in 10,000 dying to about 66 people in 10,000 dying. So that's a 1/3 increase, but going from 50 in 10,000 to 66 in 10,000 doesn't sound nearly as scary. So let's have a look at what we did. Here's the paper that actually came out, and you can see that our headline is much drier, the association between gambling and financial, social, and health outcomes in big financial data. So it's a dry headline, and because as scientists, what we're trying to do is use our data source to describe what's going on in the world, but there's no need for us to make sensational claims. We just want the data to speak for itself. So what did we do? Well, we went and got bank statement data from a large retail bank for, in some samples, 100,000 people. That's enough people. In other samples where we were looking at more rare outcomes, we needed to use a larger sample, so we were using about 6.5 million people. And these data just sit there in the bank, because every time you spend money, the bank very carefully keeps track of the transaction that you made. And at the end of the month, they send you a statement, and it's got this sort of information on it. So this is here. So someone's gone to Sainsbury's, it's a supermarket, they've spent £90. And they've gone to Ladbrokes and done some gambling, which is what we're the focus of this piece of work, and they spent £20. And then they've gone to the Red Lion pub. We know it's a pub, and they spent £10. We use nice round numbers here to keep the maths easy. And we've got this information for millions of people. And what we did was, of all the spending that you do in a month, and actually in real life you probably do more than just these 7 spends here. Can you see the mouse jumping around, Chloe and Sagros? If I point, does that work?
Yes, we can. We can see the mouse.
Lovely. Okay, thanks, Chloe. So we can see here then that out of a £200 total spend, £20 spent on gambling, well, that's 10%. Plus another £10 spent on gambling, well, that's 5% of 200. You add that up. That means that this person here has 15% of their monthly spend has gone on gambling. And what we did was, we calculated how much each month everybody spends on gambling as a fraction of their total spend. And then we also can count up other things. So we can work out, for example, that this person, well, they've spent £20 or 10% of their money on fast food as well. And so we can see other outcomes in the data. And what we're going to do on the next few slides is put those 2 things together. So here, let me zoom out a wee bit. There we go. We've got lots of little pictures, and I'll talk you through a few of them, but you'll get the sense of all of them. But these first pictures, this top row is all about things that we can see in people's bank statements that tell us that they might be in financial distress. So let's just zoom in on that and have a look at a few of them. So here, let me talk you through this graph. On this graph, we've got 101 little dots, right? The little red dot here, this represents people who don't gamble. And then all these black dots are mashed on top of one another. And actually, each dot represents not just one person, but it represents thousands or tens of thousands of people. And it's the average across all those people. And the black dot that's leftmost represents people who gamble, but they are in the bottom 1% of the population. So they're gambling very little. Whereas over here, we've got people, this 100th dot, the rightmost dot, actually it's just here where the mouse is, it's hard to see. That represents the 1% of the people who, as a fraction of their total spending, are gambling the most. And so a dot somewhere in the middle here, the 50th dot, that would represent people who are exactly halfway up the distribution of gambling, where half of people gamble less than them and half of people gamble more than them. And what we've got on this vertical axis, on the y-axis, is a measure of financial distress. And it's people going into their overdrafts when they haven't planned it. And that's typically, and certainly historically, quite an expensive way to borrow money. You get charged a fee and you also get charged a really high interest rate. So it suggests that you're in a bit of financial difficulty. And what we can see is that, you know, just under 1% of people are using their unplanned overdraft in any month. But that for people who are gambling them more heavily, so people in about the top 20% of gamblers, and because only about half of people gamble in our data, that's about the top 10% of people in the UK, they are experiencing, instead of 1% chance of using an unplanned overdraft, 2%, 4%, 6%, and the very top end, 8%. So that would be, roughly speaking, about an 800% increase in the probability of using an unplanned overdraft. An increase from 1 in 100 people, if they don't gamble at all, up to 8 in 100 people. It's always important when one talks about a risk to talk about the increase, but also to say from what to what. So here I've been careful to say it's an 800% increase from 1 in 100 to 8 in 100. The next panel looks at people who miss making a payment on their credit card, which also suggests if you can't pay a bill, that suggests you're in trouble. And we can see that uptick, gradual increase in harm, and then in the last 20% of gamblers, it gets strong. Here's taking a payday loan in the middle, missing a repayment on a loan, and over here, underneath the window with me and Chloe in, if I move that bit, missing a mortgage repayment. If you're lucky enough to own a house, missing a mortgage repayment is really bad, because if you miss too many of them, they'll repossess your house. And so we can see people missing a mortgage payment because we can see that they normally make a mortgage payment every month, and then they don't make one. And then they make a mortgage payment the month after, or perhaps a few months down the road. And we can see people missing a loan repayment because the bank flags up when you miss a loan repayment. We can see people taking a payday loan because money comes into your account from a payday loan company, and that appears as a transaction line on your bank statement. So we can infer all of these things about people from their bank statements, and it looks like for those who gamble more, there's more financial distress. People are also a bit less likely to be financially engaged, so they're less likely to have a credit card, less likely to actually have access to a loan or to be able to take out a mortgage. They're more likely to be using more of their balance on their credit card, which is a really expensive way of borrowing money. And here, a bit of a strange pattern, but again, that top 20%, they're more likely to have debt collection companies taking money from their bank account, which suggests that they defaulted on the debt and someone's chasing them for the money. They're less likely to plan. They're less likely to have an insurance product. So they're less likely to have a mortgage overall. They're less likely to be they make smaller savings each month. They're less likely to be using what's called an ISA to make tax preferred savings. They're less likely to be contributing to a personal pension. So all of those things point to people who gamble more having worse financial circumstances. But we can make other inferences about these people. So we can see things about their lifestyle. So we can see that people are less likely, there's a strange relationship with fast food and bars where non-gamblers spend on fast food and then it decreases and then it increases and then it decreases again. We don't know why that is. We didn't get clear pictures for gaming and tobacco, but we can see that people are less likely to be using off licenses. On a sort of health and well-being measure, we can see if you're looking after yourself in financial transaction data, because we can see whether you spend less on prescriptions, you spend less on items that would be counted as self-care, and you spend less on, for example, going to the gym for fitness. And we can also see a really interesting one here, which is how many nights awake do we know that you have in an average month? So people who don't gamble very much at all, they spend about 1 night awake. But people in that top 20% of gamblers, at the very top end, they spend an extra night a month awake. Now we know you're awake because we can see in the transaction data that you make on average 2 transactions where you have to have done it like in person So by that, I mean, it could be an online transaction where you've typed in your card number and the 3 digits on the back, or a purchase from Amazon, or it could be a contactless payment in a, or it could be a chip and pin. But we can see that you were awake and made a transaction. So we're not including automatic transactions like direct debits and so on. And being awake one more night, so being, roughly speaking, twice as likely to be awake, that's a marker for poorer mental health. We can also see, and this here now we're switching to the panel of 6 million people, hence the little orange line, we can see that given you're not claiming disability payments in 2013, what's the probability that you go on and claim disability payments from the government in subsequent years? And we can see that it goes from about 4% up to about 6%, so that would be about a 50% increase. Those who gamble more are more likely to be making a disability claim in the future years. We can see the same thing down here for unemployment. If you're in the top 20% of gamblers, you're more likely to be claiming unemployment. And we only chose people who were employed in 2013, what's the probability that they're claiming unemployment benefits in future years? And you can see that that goes up quite sharply. And also we can see people spend less on hobbies. They spend less on activities where you need a friend. So tennis, for example, something like that. And so we can get quite a broad view of what people's lives look like and how different people with different levels of gambling seem to have different lives. They seem to have lives that are worse in terms of their financial circumstances, but also arguably worse in terms of their lifestyle, health and well-being. This is perhaps the most surprising result that we've found. And this is a strange picture, but it's the way the experts like to plot out information about people dying. So if we look at this middle panel here, it's for a 44-year-old man, which is a topic, or nearly 44, quite close. We can see here that all 44-year-olds making bank transactions are alive at year 0, so that's about 2013. But as time goes on, some of them start to die. So the number of them are left alive gradually drops off. After about 5 years, about 0.5 in 100, so that's 1 in 200 people have died. But if you're gambling amongst the most, then that's about an extra 1/3 higher. So that's the headline that the Daily Mail had. And you can see that pattern's about the same in all of these plots. The axis here changes because younger people are less likely to die than older people, but the pattern's always the same. And it's the same for men at the top and women at the bottom. Now that doesn't mean gambling is causing people to die, although anecdotally there is evidence that in case studies that suicides have been caused by gambling. But it does mean that the kind of people who gamble more are the kind of people who are more likely to die within that 5-year period. And we can also see information about how people's behavior changes over time. So this is a picture which is showing how many people don't gamble at all in 2012. And you can see, and then all of these people here are the people who gamble, and you can see that by 2015, many more people are gambling. By 2018, that fraction has increased even more. So gambling has grown a lot over the past decade or so. That's not quite a decade, is it? That's 6 years. And we can also see people flowing in and out of the different states. And what I'm going to do is I'm going to zoom in on these people here, who are the people who are spending more than 10% of their money on gambling. So we're just going to zoom in on them. And so in 2015, this red bar, that's all of the people who spend more than 10% of their money on gambling in 2015. So it's only the top end gamblers. But what did those top end gamblers look like as we go back in time, or as we go forwards in time? Well, back in time, just about half of them were gambling really heavily 3 years before, but a quarter of them weren't gambling at all. And in fact, even the 3 months before, some small fraction of people who were not gambling at all within 3 months become really heavy gamblers. And we can also see the asymmetry in this plot. It shows you that gambling's a bit sticky. It's easier to start gambling than it is to stop gambling. So we can learn an awful lot from transaction data. And I was chatting with Chloe and Sagar yesterday, and they asked, did you do any regressions? So I actually went away and counted. We did a regression for every single thing that I've told you. I think we've probably got about 40 regressions in the paper, but I've refrained from putting all 40 regression tables in because we don't need to, because the patterns are so obvious in the data. When you have data for 100,000 people, 6 million people, you can just draw a picture of it, and you can use the regression to quantify what's going on and control for other variables, but the pattern's really, really obvious. So what to say about this? Well, there's one more point that I want to make. What if we could use our magic wands to cure those who gamble the most. So we could find the people who are gambling the very most, and I guess people often talk about gambling as an addiction, and they might say those people are addicted. Now, it's really hard to break an addiction, it's kind of by definition, but supposing we've got magic power and we just cure them, would that help? Would it fix the problem? And you might think that that would work because you see lots of gambling industry information saying things like, when the fun stops, stop. And they talk about responsible gamblers and problem gamblers. And the idea is that gambling's fine for most people. They have fun, and why can't they gamble if they want to? The rugby's on this afternoon. If you put a bet on, perhaps it makes it a bit more exciting, a bit more fun. You get some utility from that. But there's a small fraction of people who mess up gambling. They're problem gamblers. They have these really big problems going all the way through to, relationship breakup, bankruptcy, suicide. But we shouldn't ban gambling just because of those people, just like we don't ban driving just because a few people drive like idiots, or we don't ban drinking because a few people drink themselves to death. But what would happen if we cured those people? Well, what that would do to our plot, I've just zoomed in on one panel to sort of give you the idea. We'd find, this is the dot here that represents the 1% of people who gamble the most. And that dot, if we cured them, we think they'd drop down here and they'd be like the red dot here. They'd be like the people who don't gamble. And what I've done is I've shaded in the red area, which is showing the extra risk of having a payday loan, the extra fraction of people having a payday loan because they gamble. Because if they all didn't gamble, presumably they'd be like this person here. And if we just cure this top 1%, that tiny little green sliver here, that harm would be gone. But all of the remaining harm, all of the remaining extra risk of taking a payday loan is still there. And so actually, just treating problem gamblers will do almost nothing to address the scale of harm that our studies revealed. And so I think that suggests actually that we ought to be thinking about treatments that tackle gambling across the whole population as a way of reducing the harms associated with gambling, and not necessarily just tackling that small fraction of problem gamblers. So just to wrap up this bit, and then we'll sort of touch on some of these issues in some of the other topics. Gambling is associated with harm. Even at low levels of gambling, those gambling more experience more harm. And either that means that gambling causes harm, or, and I'm not sure this is much better, those who experience the most harm for whatever reason also happen to be those who gamble. Perhaps put slightly differently, the gambling industry tackles those who are in the greatest financial difficulties, or those who are in the greatest financial difficulties are drawn to something that probably isn't going to help them. I think this work complements what's known before, which was typically surveys of problem gamblers where they try and ask people, how much do you gamble and is it a problem for you? But they're only asking a few thousand people. And it's very hard to get in touch with people and to answer a survey if they're just about to lose their home. And I think only a really large retail bank has this view across the whole population of not only how much people gamble, but also everything else that they do. The government couldn't do this. The gambling industry couldn't do this work. Surveys can't get you this result. So I think in that sense, this is an example of how we can use data that's getting recorded anyway. The banks have got to keep track of where the money goes because that's the part of the purpose of what a bank does, is to facilitate the flow of money around the economy. They're doing that anyway, but we can use those data to understand the problem that society has. And then that evidence hopefully can be used going forwards to make better policy decisions about how one might regulate the industry. So that's what I wanted to say about gambling. Where was I going to go next? Let's talk just a little bit about jumpy and sticky numbers. Here we are. This is work which Hero led, who's the chap in the pub from earlier on. We're looking at people who are repaying their credit card bill. And there, what happens is you get a bill at the end of the month and it says, Neil, you owe us, say, £2,000, and you must make a minimum payment of at least, say, £20. But you can pay us any sum of money between the minimum of 20 all the way up to the 2,000 you could pay. So how much do I choose to pay? Well, if I don't pay off all of the money, I'll pay interest on it, and the debt will be carried over to the next month where I've got another decision to make. So if I only pay the minimum, I'll be paying interest on £1,980 at about 20% APR, which is pretty high. If I pay it all off, then that's great, but I haven't got any money now because I've spent all my money on paying off my credit card bill, so I can't go to the pub. Oh, that would be nice, wouldn't it? So I might choose some intermediate sum of money. I might choose, and the idea would be is that I'm supposed to trade off how much can I enjoy this money now versus how useful is it? How much utility do I get from paying down this debt so that I don't have to pay interest in the future? And I trade those things off and I come to some sum of money. But what do people actually do? They're not doing this. They're not trading off money I can use for enjoyment now or other activities against money in the future. What I've got here is a graph that's just showing that the most frequent thing people do is to just pay £100. If they don't pay £100, they pay 50. If they don't pay 50, they'll probably pay 200 or 150 or so on. And all of these spikes are the sums of money that people actually repay. Hardly anyone's repaying, say, £90, that's £95 or £90, or they're not paying these non-round numbers. People are really drawn to pay nice round numbers. And that suggests to me two things. One is people really don't know how much money they should pay on their credit card bill. They're just like, pay 100. Probably a second observation is I don't know of any economic model that when you gave it this problem and said, should you pay your credit card bill or should you use the money for something else now? Those models will come out, you need to know something about someone's preferences for money over time and the other options they've got available for the money and all that kind of stuff. And it will come out with an answer as to how these things should trade off and what you should do. The answer, they won't just go 100. But that's what people are doing. And it's just blindingly obvious people are just going for 100. In fact, 13% of people pay 100. 9% of people pay 50. 6% of people pay 200. And these round numbers here, that adds up to 60% of all payments on credit cards are one of these round numbers. And then we can do an experiment, actually. We can think. Well, it's not an experiment. It's an experiment that's there just sitting in the data. A natural experiment, we would call it. And what I've done is I've compared people with ever so slightly different credit card balances. And because the minimum payment's always about 1% of the balance, they've got ever so slightly different minimum payments. So all these people owe virtually exactly the same amount of money. But some of them get a minimum payment that's in the range £99, £99 and 1 pence to £99.99. And some of them get a minimum payment that's over 100. So between 100 and 101 pounds. Now this is a really trivial difference. It's £1 out of 100, right? But let's look and see, what do people do? Well, if people have a minimum payment that's 99 something, we can see a massive great spike of people paying exactly £100 off. But and then they're paying, what's that? 100, that's 110, 120, 150, 200. So lots of people are paying more than that £99, whatever minimum. But once the minimum's just crossed over 100, so you've got a slightly bigger minimum, you can't pay 100 anymore because otherwise you get a fine. So that 100 round number's off the table for you now. And what I've got here in the blue lines, and I've drawn them in dark blue and drawn them skinnier so you can see the two together on top of one another. The skinniness of the bar is irrelevant, only the height matters, it's just a visual aid. But we can see that no one's paying 100 anymore because you're not allowed to because you get a fine. A few people are paying the minimum, which is about 101 now. But look, lots of people have started paying 110. Loads more people pay 110 or 105, 110, 120, 150. And the idea there is it's almost as if, what's the next number after 100 for these people? Well, it's not 101. The next number after 100 in these people's minds is 150 or 110 or 120. And we can see that as the minimum payment, and this is a complicated graph and I'll go quickly, but as the minimum sweeps up through, what would that be? That'd be 96, 97, 98, 99, 100. As soon as the minimum crosses 100 and goes to 101, 102, 103, 104, the jump in people paying £110 is a really big jump. And what that means is that people aren't dealing with money as if it's a smooth, continuous quantity where, it's not completely continuous because you've got 1 penny increments, but it's roughly a continuous quantity. People are treating money as if it's categorical, right? As if the next number after 100 is 150. To keep Chloe and Saigo happy, I did some regressions which show you the same pattern. But the conclusion would be that people aren't thinking about money in the way that perhaps economic models treat it as a continuous quantity. Instead, people seem to be thinking about money as a categorical quantity, and as soon as they can't pay 100 anymore, they just jump to 150. Let's have a look at the time. Do you know what? I'm going to tell you a bit about domestic abuse because I think it's really important, and then I think we might stop there. Let me find something on domestic abuse to tell you. Here we go. So the two examples I've shown you so far are all about transaction data from banks, but other organizations also just record data routinely. And so we did some work with the police who record data about all of the crimes that get reported to them. And we're particularly interested in activities that lots and lots of people do, because if you study those and you can make changes to those behaviors, you can affect a large number of people. And that gives your work as a behavioral scientist the greatest possibility of doing some public good, I guess. And one of the things I didn't realize about domestic abuse until I started studying it, so the data we have were all of the crimes and incidents that West Midlands Police, which is the police force that police where Warwick University is, where I'm speaking to you from a bedroom upstairs in my house, but that's where I'm an academic. So West Midlands, all incidents for that 8-year period, domestic abuse is about 1/3 of everything that the police do. Now, I thought they were out catching robbers and stuff like that, but it's domestic abuse. The other one's mental health, right? And of domestic abuse cases, about 23% of them, the police flag up when they arrive at the case as involving alcohol. Somebody's intoxicated. And what we wanted to look at was how domestic abuse and alcohol are. So I guess domestic abuse, typically it's male and female, and it's very common that it's a male abusing a female. It's domestic abuse or intimate partner violence if you're in an intimate relationship, but domestic abuse also encompasses just two individuals living in a house together, which is what we can see. So it could be father on son, two sisters, anything, right? But and what we wanted to look at was how is masculinity and then this intimate partner relationship linked with alcohol? And what we did, and it sounds a bit frivolous, but we used football tournaments as a moment when effectively the hand of God comes down and gives the population a large dose of alcohol, because people drink a lot during the World Cup, right? And well, this one will keep you regression happy people going, but this is a horrible regression table, but the one that we care about, where's the coefficient that we care about? It's in here, right? It's this one here. This number here in this linear regression. It's not actually linear regression. I think it was a Poisson. Let's not get into that. It's an over-dispersed Poisson count data model. But what that 0.606 means, and all we've done is use really boring off-the-shelf econometrics, the standard techniques you get taught at university in your first and second year. We've used that to try and quantify how much domestic abuse goes up. And what we found was it actually really goes up, and this means it goes up by 60%, and I'll tell you a bit more about that increase in a moment. It goes up by 60% on days when the World Cup is on and England wins, but it only happens for cases where alcohol is involved. Right? When England draw, there's not a big change in abuse. When England lose, there's not a big change in abuse. When England win, but nobody in the house is drunk, there's not a big change in abuse. It's this coincidence of England winning and alcohol being involved that creates this increase in domestic abuse. And it's quite a big increase in domestic abuse. It's gone up by 60%. And then we can do loads of stuff. We can look and see, and these regression tables just are telling me the story. I'll just sort of narrate it for you, but I don't expect you to follow the details of the table. Men abusing other men, there's an increase, but we've got very low numbers of men, so it's very poorly estimated. There's the increase for male on female domestic abuse. We don't have so much evidence for female to female. Female to male, there's an increase, but again, it's not so reliably estimated because it's much more rare that this female. There are large numbers of females abusing males, but it's much rarer than males abusing females. So here's another interesting one. These models compare different types of crime, and we can see that we only see this England win effect, not in crimes related to property like burglary, not in public order offences like being stupid in the street outside a pub, not in hate crime where the crime is motivated perhaps because of someone's sexuality or their ethnicity. It is in violence, people being violent to one another. And when we look into these figures, it's men being violent to women. When we look into this figure here. So it's actually not men beating each other up outside the pub, it's men beating women up outside the pub or in the home, who are not typically in a relationship, otherwise it's called domestic abuse. And then because we've got the timing, we know when all these calls come into the police, we can see that this is the time when England draws, and in the middle here, this is when the match starts, during the match. And you can see that the difference between alcohol-related abuse and non-alcohol-related abuse, that's the colours, pretty flat. When England lose, there's maybe something. when England win, there's a big increase in domestic abuse, but only for those cases of abuse where alcohol is involved, not these other cases. What's that telling us? Well, one study alone doesn't tell us a lot about domestic abuse, but I think what it's looking like is that we've got more evidence about the relationship between the role that alcohol plays in male and female domestic abuse. The idea is that something about the masculinity, concepts of masculinity that are raised when your team wins, interacts with alcohol, so reduced inhibitions from the effects of alcohol, and manifests itself as increased male to female violence. I think like most things in science, you can use it for good or bad. So hopefully with the use of data that we've got at the university, we have considerable ethical oversight that keeps track of how we're using the data. And you can use the data for good, I think. But it's clearly possible to use the data for bad and probably also use the data for marketing, which is mostly what seems to be happening. I guess it also raises issue about who has access to this data and where do these data sit. So for example, why didn't we already know about the harms associated with gambling beyond the case studies and the surveys? And actually I think what our study's done there is to show that the harms associated with gambling are probably much larger than we thought, and they affect probably up to half of the UK population. But why didn't we know that? And it's because the data is sitting there in retail banks. And the reason we got access to the data was because we happen to know some of the people in the bank, and in the bank they have a customer vulnerability team who uses who tries to do things for the good of their customers, and this project took off. But if that data were available just generally and freely to all scientists, and there are ethical issues about whether that's a good idea or not, but we could have known this years ago. So I think I'm agnostic in the sense that one has to consider the individual use of the data, whether it's a good or a bad use. We've got quite good regulatory oversight in the university sector for doing research to work out whether what we're doing is okay or not. And I think that's coming. But I wouldn't want to come to a good bad verdict. I'd try and come to a separate good bad verdict on each individual use of the data. On cigarettes, it took a very long time to deal with cigarettes. The evidence was there that cigarettes were addictive and harmful decades before action was taken. Gambling has only really grown and grown and grown. There are two reasons why. One is during New Labour, so it must have been about 2005 or thereabouts, there was a big deregulation in the gambling industry, and the gambling industry has grown a lot since then. And the other one is now, if I want to gamble, I can gamble anywhere, anytime, on anything on my phone, right? And it's there continuously, and alerts will pop up to help me gamble. So I think the environment on gambling has changed greatly in the past maybe 20 years or so. And so if there is a problem, it's the deregulation has let it become much bigger. And then second of all, it's this point about who is it who could see this? Who could know? Well, the government couldn't know, because they see the tax take from the gambling industry, and they can ask the gambling industry to report some statistics to them. And they see some information from the NHS, maybe some people get referred there for gambling problems, but they don't have a very good view. The gambling industry doesn't have a very good view, because they can see people spending money, but they can't see lots of extra information about the trouble that they might be getting into. It's only really a small number of retail banks that could do it, which means that the ability to look at this problem is in the hands of actually quite a small number of individuals on the decision about whether to look and share the data. I think probably as a public good and doing work that will make things better in the world, sharing the data with us was quite a brave move from the bank, because they don't have anything to gain from it themselves, apart from trying to help society, and that's why they did it. So I think there's the sort of, it's timely at the moment. It perhaps wasn't such a pressing thing to look at 10 years ago. Yeah, so I think it's not. If we had a different society where there was no market and everything, and if there was any gambling, it was all state-run. A state-run monopolist perhaps could have done this, could have done it, but that's just not the way our economy's set up. So there's always a question of whether it's cock-up or conspiracy. It's probably just, I think it's probably not terribly sinister. There's plenty of money involved in the industry. There's a powerful lobbying side against gambling, but then for leaving gambling unregulated. There's lots of money in that, millions and millions of pounds, billions of pounds. But there's also a very powerful narrative coming from harm of survivors of gambling or relatives of